So the questions that we're going to answer are 3, 5, 6, 7, and 8. So, number 3, they're giving us a function, and they're saying the graph is shown below. What's the value of g inverse of 2? By the way, that's how you read that, g inverse of 2. So typically, you have f of x equals y. When it's in the inverse function, if you're looking at the original, that's the original g graph. This is actually them giving us the y coordinate, and we need to find the x that goes along with it. So if I look at the y coordinate, or the y-axis right here, the y equals 2, it's crossing right there at -1. So the point on the original graph is -1, 2. That's the point on g of x. In other words, g of -1 equals 2. Therefore, when you do the inverse, g inverse of 2 is going to equal -1. It goes backward. So the answer is 4 there. Okie doke. In 5, for a 1-to-1 function, so that's when no x's repeat themselves and no y's. We have 0, 6 is a point, and 8, 0 is a point. Which of the following must be true about the graph of this function's inverse? Now think about on the original function, 0, 6 is the y-intercept. If that's the y-intercept of the original, it's going to become the x-intercept of the inverse, because 0, 6 is going to become 6, 0. So the x-intercept is 6, which is not an option. And if the original x-intercept is 8, so that's 6 and that's 8, and again, this is the original. If the original x-intercept is 8, then the inverse's y-intercept is going to be 8. All things x and y switch. So on the original, 0, 6. On the inverse, 6, 0. If instead you say on the original the y-intercept is 6, then on the inverse the x-intercept is 6. Everything switches. X's and y's switch. Okay, that's the overall general concept of inverses. Okay, 6 was, most people definitely had a question on 6. I'm going to throw that light on. I don't know if that helps or not, but the shadow is the shadow of my document camera. The function y equals h of x is entirely defined by the graph shown. Okay, this is h of x. Sketch a graph of the inverse. In order to sketch a graph, you take any point you can and you flip-flop its coordinates. So, for instance, this coordinate is -1, 2, 3, 4, 5, -1, 2, 3, 4. -5, -4 is going to change to -4, -5. This next point, -1, 2, 3, 4, -3, -4, -3 is going to change to -3, -4. The next point I see, -1, -2 is going to change to -2, -1. And the last point that's on the original, 1, 2, 3, 4, -1. 4, -1 is going to go to -1, 4. And here is the image of those 4 points when you connect them. Now this to me always looks like DNA, like these things wrapped around each other. Here's the line y equals x. The original function and the inverse function look like it's been reflected over that line. And that's the whole switching of the y and the x. So create a table of values if needed. I kind of talked through that. So the domain and range of the original. So domain, we're going to look at the original. It's how far left on the x-axis to how far right. So the furthest left was -1, 2, 3, 4, 5. So from -5 all the way up to 1, 2, 3, 4. Which At the bottom, I'm noticing my answers are written in a little bit of a different notation. -5 to 4 with brackets means the same thing. That means anything in between -5 and 4 is on the original domain. And for your range, the lowest value, 1, 2, 3, 4, the lowest value of your original is a y of -4, and it goes up to here, which is a y coordinate of -1. Here's -1, -2, 3, 4. So anywhere between -1 and -4 is where that original. And you always go smallest to lowest. So -4 is less than or equal to your y values, less than or equal to -1. That's our way of writing smallest to biggest, that y is always staying between -4 and -1. Or again, you can do this notation here. To get the domain and range of your inverse, you can look at it just like we did the first one and say, okay, well, where's the furthest left to the furthest right? How far low to how far high? But the beauty of already having the regular function is that everything switches. So the domain becomes the range, and the range becomes the domain, because all things x and y flip. So your range is now -5 to 4, and your domain is now -4 to -1. So those things all switch. Any follow-up questions on that? Okay, number 7 gives us, that's actually the area of a circle formula in a chart. And we have up until a radius of 6 and then all of our corresponding areas. So determine the values of A inverse of 9 pi. So remember, A inverse of that's a y of your original. So you go to 9 pi and the answer is 3. And A inverse of 36 pi, go to 36 pi, back to 6. That's fairly straightforward. Someone asked about B. B, you would just have to extend your table. So if your R is 7, pi 7 squared would be 49 pi. If your R is 8, pi 8 squared would be 64 pi. So what would 100 pi be? Pi R squared, R would have to be 10. So this is 10. And 225 is 15 squared. So your 15 squared pi would be 225 pi. So that's just kind of doing a continuation of the table. And then on part C, we have the original function converted an input, which was the radius, to an output, which was the area. What are the inputs and outputs of the inverse function? Just flip it. In the inverse function, the input is the area, and the output is the radius. I'm going to go with that because it's easier to see. And then lastly on 8, the domain and range of a one-to-one function f of x are given below. Okay, domain, range. Give the domain and range of this function's inverse, also in set builder notation. So set builder notation was pretty much what I was doing up here, except for I just didn't do the set of all x's. So what this technically means for the regular function is that the domain is the set of all x's such that x is between -3 and 5. Notice on this one that x can actually equal -3, but it has to stay less than 5. On the range, y has to be just greater than -2. So what do we do for the domain and range on the inverse? Flip them. Now, instead of using y's, I'm going to use x's. So it's the set of all x's such that x is greater than -2, because domain always has to be your x coordinates. And your domain numbers become your range. So the set of all y's such that -3 is less than or equal to y is less than 5. Great. Yep, no, you can. We're going to actually, there's a section on that, but I will show you because it's a good question. If you're doing it in that interval notation from -3 to 5, you would do a bracket on the -3 because of the less than or equal to. and just a parenthesis on the 5 because you're not including 5. And for the range one, think about y always having, and I'm just going to use a number line so you can help visualize this. If y always had to be greater than -2, interval notation always has to go from low to high. So on the low end, this could be up to but not including -2, so that would be a parenthesis. And on the high end, it never stops, and that's where your infinity symbol will come in. But that actually kicks off the start of our next chapter. We'll talk more about like the brackets and parentheses and stuff. Okay, good question. All right, so this is always kind of a tougher concept to like see for the first time, which is why we're going to spend another day on it. Okay, so the next page in your packet is